Hi, so this is D1, Intrinsic Viscosity of Polyvinyl Alcohol. So here are some of the materials that we'll be using. We're going to be using DI water as our solvent, and then you need some glassware, so we'll be using Erlenmeyer flask in order to make our stock solutions. And then our solutions after there, our diluted solutions, you're going to be using volumetric flasks. Then our reagents that we're going to be using, obviously we're going to be using polyvinyl alcohol, so make sure to look at the SDS for this, as well as potassium periodate. That's what we're going to be using to cleave our polyvinyl alcohol, so make sure to look up the SDS for that as well. We're going to be using, of course, the star of this experiment, our viscometer. So we're going to be using type 50 mil viscometer. It means it holds 50 mils from the top line to the bottom line. We'll also be needing a thermometer. We'll need to make sure that we can read 85 degrees or less. So we have a thermometer. We also have some volumetric pipettes, 10 mils and 50 mils, and also a pipette bulb. But before we can get started, you want to make sure that we have all of our PPE on. So I have my safety glasses on, I have my gloves, my lab coat properly buttoned, and then closed-toed shoes and long pants. And also we'll be using some glass wool in order to filter our solutions. So that should be the last thing that we'll need, and then we can get started. Okay. How's the temp? But you can definitely take a picture of it when I'm done waiting. So now we weighed out our polyvinyl alcohol so we can add it to our heated up water. So we got between 2 and 2.25 grams. And the exact amount, you just want to make sure that is recorded. That will be on your Excel sheet. It doesn't have to be exactly 2 or exactly 2.25 grams. You just want to make sure that you know exactly what the mass is, so you have the correct concentration. So now that we're at about 81 degrees Celsius, we want to turn down our heat just because we know that the heat will continue to rise to about 85, but we want to make sure it doesn't go any more than 85. When we add our polyvinyl alcohol, and if we get to 85 degrees, then there's a chance that our polyvinyl alcohol will char. So you want to make sure that you avoid any higher temperatures than that. So we'll add our 2 grams. We want to slowly add in. Slowly add in some at a time. Continue to stir. All right, so now we added all of our polyvinyl alcohol. We just want to make sure that it's all dissolved and that we don't hit above 85 degrees Celsius. So it should take about 40 minutes to dissolve at 85 degrees, but we'll come back when it's fully dissolved. So while our polyvinyl alcohol is dissolving at about 85 degrees Celsius, we also want to heat some DI water. This will be used to clean our viscometer out rather than using any acid that we've done in the past. And maybe the lab manual says that we use acid as well as the source, the text source. So you can read both those sources, but we just have a slight change where we're just going to be using warm DI water. So we're just going to warm it up on a stir plate, maybe about 70 degrees or more, that's fine. And we'll be using that with pipettes in order to flush out any leftover solution in our viscometer. So it's been about 40 minutes and we see that all of our polyvinyl alcohol has dissolved. So we want to now filter with glass wool. So we've attached a funnel. We have our glass wool packed in there. And now we're able to transfer. Now our flask is hot, so we want to be careful and use gloves. So I'm going to use heat protective gloves here. But you want to be extra careful when using these gloves as well because you might not get as good of control. So now we'll take our solution. Remember, it's very hot. and we want to filter through our glass wool. All right. So now we have about 200 mils. Once we've added all of our 200 mils to this 250 ml volumetric flask, we want to let the solution equilibrate back to room temperature before we fill to volume. So I want you guys to think about, why do we want our solution to be at equilibrium temperature before we fill to volume? Why can't we just keep it at 85 degrees Celsius? So now our 200 mils of solution has equilibrated to room temperature, and we want to make sure that we quantitatively transfer over our solution. So what you want to do is just rinse your flask, and we have DI water, that's our solvent. So you just want to make sure you rinse your flask properly, and then you want to rinse it in. And you want to do this maybe about 3 or 4 times, and then you can fill to volume with water. So that's the proper way of quantitatively transferring a solution over. Now we can just fill up to our fill line with DI water. Okay. Perfect. So now we have our uncleaved stock solution, and you just want to invert slowly a couple times just to ensure proper mixture. But you want to avoid foaming, so you want to work slowly with this process. And then after this, we're able to make all of our dilutions of our uncleaved solution, and we're also going to make our cleaved solution. Now I've added about 25 mils of DI water to this new Erlenmeyer flask. We're going to be making our cleaved stock now. So we're going to need 50 mils from our uncleaved stock, and we're going to be using a volumetric flask or a volumetric pipette in order to transfer. So we're going to be transferring over 50 mils, and then after we transfer our 50 mils over, we will want to add 0.25 grams of potassium periodate. And we want this solution to be stirring and heated up as well, so that it can facilitate the dissolving process of the potassium periodate. So now we want to transfer our 50 mils over. So you only want to make sure that you have exactly 50 mils of your uncleaved stock, and that's why we're using a volumetric pipette. Now you might want to think about, why are we using a volumetric pipette versus using another form of glassware like a graduated cylinder or something like that. Okay, great. Now the water, since we only added about 25 mils, it doesn't have to be exactly accurate because we'll be filling in a 100 ml volumetric flask, so that we can ensure it's 50 mils of water. So now I've weighed out the correct amount of potassium periodate. So we have about 0.25 grams. So we can take this over, and we can add it back into our stock, and this will be our cleaved stock. So you want to slowly add. Okay, great. Now we're just going to wait for this to dissolve, and then we'll come back. Now all of our potassium periodate has dissolved, and we can transfer over a 25 degrees C bath, just so we can equilibrate back to 25 degrees C. Now we'll leave the stock in there to equilibrate to about 25 degrees C. We'll come back and we'll quantitatively transfer to 100 ml vol flask. Okay. Now our cleaved stock is about 25 degrees Celsius, so now we can quantitatively transfer to 100 ml vol flask. Now, quantitatively transferring, you want to make sure that you're not losing any of your solutions, so it's a good idea to rinse your stir bar. Now we can transfer over. Now, as was mentioned before, when quantitatively transferring, you just want to rinse your vessel or flask a couple times with your solvent. So I'm just going to rinse here a couple times. Transfer over. Remember, you don't want to add too much volume, otherwise you can go past 100 mils. So you'll have to be careful of that. Great, now that we've quantitatively transferred over our cleaved stock, we just want to fill the volume. All right, now that we filled to volume, you just want to once again invert to mix. And then now we have both our cleaved stock and our uncleaved stock, so now we can proceed to our dilutions. So now that we made our cleaved stock, we can make our first dilution. And for all the dilutions, it will just be 50 mils transferred over with a volumetric pipette and then filled to volume with DI water. So just as we did before, we want to take 50 mils. Great, and we want to transfer over. Okay. So now we'll add the 50 mils of the cleaved stock, fill the volume with DI water, invert to mix, and we'll do the same for the second dilution, and we'll do the same for the uncleaved dilutions as well. Now, once we've made all of our dilutions, you should end up with your cleaved stock, dilution 1, dilution 2 of your cleaved, your uncleaved stock, and your 2 dilutions thereafter. Now, you want to make sure that you get at least 2 or 3 trials for each the stock and each of the dilutions, and that will be in your Excel. So check your Excel for those results. So you want to make sure that now we can go use the viscometer and find the time, and then solve for viscosity after that. Now, before we take the viscosity of any of our samples, you want to make sure that you do a water calibration. So you want to do that every day. You want to do at least 1 or 2. Check the Excel to see exactly how many water calibrations were done that day. So you want to put water either in an Erlenmeyer flask or beaker and make sure you let it equilibrate to 25 degrees C, same as you do with any of your other solutions, before you actually take the viscosity of your sample. So we're just going to take 10 mils using 10 ml volumetric pipette. Take 10 mils of the equilibrated water, transfer it to our viscometer, and then we're able to start our water calibration. So you want to grab about 10 mils, carefully transfer to the viscometer. And now you can dispense your 10 mils, and then after we dispense, we can draw up and start our time. Transfer our 10 mils of water over. We just want to draw up with a pipette bulb, and you want to get to at least the first marker and above that, and that will be the first time. Once you hit the first mark, then you'll start your timer. So we'll draw up our water. So now that we pulled up our solution through and we pulled it up past the green line, we'll just let gravity pull down our solution, and then once the meniscus hits the top of our green line, then we can start our timer. Now we see our solution is dropping. Once the meniscus hits the top, we'll hit start. And then now we want to stop the timer once we get to the bottom marking. Once the meniscus hits the top of that bottom marking, then we stop our timer. Now we want to stop the timer once we hit the bottom line. Ready, and stop. So now that was our time that it took for one trial of the water calibration. And you'll repeat this either 2 or 3 trials. And then you want to make sure you do a calibration every day. This will be the same procedure for all of our sample solutions. And we'll show one of the sample solutions, but it'll be the same for all the other solutions. Now for the first solution, I'm going to take our cleaved dilution 2. So this is our most dilute solution. Now I want you to think about why are we going to use the most dilute solution first? Can you go in any order? What are the advantages and disadvantages of starting with this solution? Now you want to make sure that we let this equilibrate for 10 minutes again to about 25 degrees C before we transfer it over to our viscometer and then take our measurement. So we'll come back after the 10 minutes.
Yep.
So now it's been 10 minutes. Now we're able to pipette 10 mils of our solution into the viscometer. Great. Now you can transfer your 10 mils over. And once this is transferred over, then we can take our measurements. Now we completed 3 trials of our dilution 2 of our cleave solution. So what you want to do is just do 3 trials of each. You don't have to empty out your viscometer and refill. You can just do 3 of those trials. Now you want to make sure that you clean thoroughly your viscometer. You can use hot water and then you can use acetone and let it dry with air. You can also thoroughly wash it with your next most concentrated solution and work your way up. This way you kind of avoid that carryover. So let's go and clean our viscometer. So like any waste, you want to make sure that you're not adding waste to a waste container that is not meant for that type of waste. So we see that we have, this is for experiment D1, and we can add polyvinyl alcohol to here. We can add water. So before we do that, we're going to need to grab our hot water. So let's go do that. So now our hot water has been stirring, and it's maybe about 70 degrees Celsius. So we can use this in order to clean our viscometer thoroughly. Now remember, it's very hot, so you want to use heat protective gloves. Now we completed 3 trials of our dilution 2 of our Cleve solution. So what you want to do is just do 3 trials of each. You don't have to empty out your viscometer and refill. You can just do 3 of those trials. Now you want to make sure that you clean thoroughly your viscometer. You can use hot water and then you can use acetone and let it dry with air. You can also thoroughly wash it with your next most concentrated solution and work your way up. This way you kind of avoid that carryover. But so let's go and clean our viscometer. So like any waste, you want to make sure that you're not adding waste to a waste container that is not meant for that type of waste. So we see that we have, this is for experiment D1, and we can add polyvinyl alcohol to here. We can add water. So before we do that, we're gonna need to grab our hot water. So let's go do that. So now our hot water has been stirring and it's maybe about 70 degrees Celsius. So we can use this in order to clean our viscometer thoroughly. Now remember, it's very hot, so you want to use heat protective gloves. So now you can dump out your solution, since we know that this is the proper waste container. And you want to rinse with the hot DI water. You want to do a few times just to make sure that you're being thorough. So I want you guys to think about, why do you want to be so thorough with your cleaning process? How could this affect your results if you don't clean your viscometer very well? So you want to make sure that you pull the hot DI water all the way through your capillary and up to the region where you filled your solution up to. Okay. Now you can pour some